Hello everyone, welcome to my presentation. As you can see, my name is Guo Jianting. Speaking here, my English is limited. I have appreciated your patience with my essence. As the title shows here, Uncentralized Artificial Intelligence Computing Agent with the distributed training and computing test based on the open source cloud Proxy. I have divided my presentation into 4 parts. First of all is the introduction. In this part, we will talk about the study abstract and make a simple introduction to this study. Secondary, talk about the technology we use and when or where can use this system. Thirdly, talk about the proposed system, and in this part, we'll take part in the distribute system algorithm and the related formula. And the final is our conclusion for this study. Due to the visualization of the GPU is still not open or available for free development based on the open source cloud computing platform. To maintain or balance the cost and the huge computing resource is quite hard for a single machine. So we propose this study. In this study, we propose a cloud proxy, which is for researchers or who need to use any AI algorithm, not only the inference action such as object detection, image processing, and recognition or trend prediction, but also the training algorithm. The proxy provides the user to upload corresponding data to train an AI on the cloud. To maintain the GPU computing resource, the distributed system is used. Our proposed framework is similar to the MapReduce structure, which is provided by the Google. MapReduce is the distributed system framework, which is used to solve the huge dataset and parallel computing. Based on this framework, we only need to define how to allocate text. In other words, how to assign text more effective. The detail on centralized AI computing agent will be explained in later session. The cloud proxy provides 2 types of tasks: the training type and the computing type, so that the user can choose on their demand. In this study, we mentioned that we use a JSON Nano with 4 GB memory as a nano node on the computing test, which is used lower CPU computing resource instead of using the cloud computing node. On each nano node, we use Docker container for rapid establish the system environment with the test needed. In this part, we will talk about the related work. We'll focus on the researchers which can use this parallel the process at the same time for enhancing the performance. As the researchers we found, some researchers will use the genetic algorithm for searching the optimal solution. We can divide the procedure of the genic algorithm into multiple partitions. The corresponding computing loads are distributed into multiple computing nodes for further processing. For example, the virus crossover method can be parallel processed at the same time for enhancing the performance of the genic algorithm. Docker engine. The previous session we mentioned that we use the JSON Nano as the nano node instead of using computing node. On the JSON Nano, we use Docker container to rapidly establish the environment, easily separated the environment with others. The developer can also easily develop the AI algorithm for a certain container or certain actions, such as the container A use the PyTorch as the AI framework, and container B use the TensorFlow as the AI framework. GPU sharing, chance, text, QoS, and not every embedded GPU platform supports the GPU sharing. In one paper, we found that they have a way to share the GPU. In that paper, the sharing framework is called tCUDA, but in our study, we provide the distributed system to share the GPU computing resources. Not only the GPU computing resources are shared, but also the CPU computing resources do as well. Considering the online AI service or training, various remote user would upload the corresponding computing mission or test for further processing. Since the visualization of the GPU is not available for the public, to cluster and group multiple physical GPUs would be the possible solutions. In our study, proposed three systems. First is the uncentralized AI computing agents. Second is distributed training task and computing task for computing work assignment and processing. Third is the load balancing and performed evaluations based on the open source code Proxy. In this slide, we introduce the first system. In this session, the agent is introduced. Generally speaking, the agent is the container which includes the related data, the training data or application data. The agent is like providing the procedure when the user is using the application or the training action. So the procedure has two types: application procedure or training procedure. When the remote user is using the object image recognition, the on-demand agent or code container can be provided, and remote user can upload the agent's procedure with the related data. So not only the deployed container from the proposed system, but also the upload containers from the remote user are both engines. Furthermore, an engine is a container. A container can run a corresponding AI algorithm, and a container can be implemented in a format Docker container. By using Docker container, the Docker engine provides a vast platform can use the container, so we can establish the container in any platform. In our study, when processing the procedure or algorithm included in a container, the container could be relocated to the selected computing node of the cloud for further processing. Hence, each container as the independent agent can develop the requested AI application based on the multiple uncentralized computing nodes. In other words, based on the cloud platform, multiple agents with various AI applications can be parallel processed. Once the agents are independently processing, we can make sure each computing node will not cause any affection to another agent. At this session, we are going to talk about the detailed task, how task is allocated, and how to calculate workload of the computing nodes. Since each agents are distributed to the computing node of the cloud for the further processing, to enhance the performance of the computing and processing, we use a physical computing node rather than the virtual machine with more computing resources. So the container or agent should be processed by a single computing node with no computing resource. In this study, similar to the head hub mass-reduced structure, the agents of the AI computing or training is deployed as an individual task, considering the computing resource required. There are two possible types of computing tasks: training task and computing task. In training task, to consider the training procedure may be huge. The agent with the task is assigned to the computing node with GPU and more CPU resource and more memory resource. When the training task is finished, it will generate a weighted file or training report that this can be used as an AI service. When using this AI service can regard this as a computing task, different from the training task. The computing task according to a weighted parameter and files needs more GPU computing resource instead of the CPU. Considering the GPU computing resource and the cost. On the computing task, we use the JSON nano instead of the computing node. Now, we know all details about the task. Let's talk about how to allocate depends on its workload. The workload of the individual nano node can be estimated as the average time for completing the computing task. That's to say, after computing many times of the corresponding computing task, after many updates, the accuracy of the average time can be higher. The formula is defined as below. The NK means the total N processing time corresponding to a KTH computing task. Each time processing was spent computing TK. Therefore, the average time for processing the corresponding text TSK can be estimated. At the last part of the processing system, we introduce the load balancing and the performance evaluations. In this study, all states are distributed to each computing node or node. We propose two formulas, which is shown below: the Formula 2 and the Formula 3. Formula 2 shows the total estimated time on the nano node, which the T and E, the N stand for the MTH node, nano node, and the E stand for estimate. In this formula, the text should be distributed to the nodes in the cloud. That's to say, in the formula, the TSK is to a certain MTH nano node. After finish the procedure, the nearest accuracy time slot. And the formula 3 is an objective function, which Tn equals Tnp plus Tne, and the Tnp equals Tsk, which the procedure is under processing. So, for a given objective function, we can minimize the processing time by assigning a task to a different nano node with different time slots. We also make a simple verification and simulation result shown as this table and the figure. The table is the type of the user's device, and the figure 2 is the difference of the training time corresponding to the laptop, JSON Nano, and the cloud computing node. With various computing resources, figure 3 is the difference of computing time with various computing resources. As you can see, the most training time based on the cloud computing node would be only 43% of the JSON Nano, and on the air service, to use the JSON Nano with only 14% cost of the laptop. So JSON Nano can be the solution for the AI service or application development. In this study, the Uncentralized AI computing agent, which includes the distributed training or computing tasks, can be processed by different hardware devices corresponding to the cost. Due to the time required for the training task, the agent will be processed on the cloud computing node for reducing from the 50% processing time, which is estimated in hours. In this study, the most time difference could be more than 5 days for training, positions. The computing task with less processing time can be distributed into multiple nano embedded system devices with less cost than laptop or car computing nodes. Okay, this is the end of my presentation. Thanks for your attention.